This is Mr. Holsey with H Squared Sufficiently Understood Science, and in this tutorial we'll be learning how to calculate potential and kinetic energy. Now, let's say that I wanted to calculate potential energy. So potential energy is an object or system that has the energy that an object or a system has due to its position or arrangement. And so we have a very simple formula for this. We have gravitational potential energy. It's often going to be just written as P dot E, okay? Potential energy is equal to mgh, where we have mass, gravity, and height. All right, let's say we want to go ahead and calculate potential energy, gravitational potential energy. And so let's go ahead and do that. So we have our formula, PE equals mgh. And so we're going to be using that to calculate for our formulas. So we know the formula. So let's go ahead and just write this out. Let's go ahead. We'll have P dot E equals, okay, mass equals gravity, little g, equals height equals. So let's go ahead and read the question. So calculate potential energy of rock sitting on the cliff. The rock has a mass of 10 kilograms, and I'm going to go ahead and underline that. Mass of 10 kilograms, and it's 10 meters from the ground. So that's telling us our height and our mass. So we can go ahead and pop those in. We have 10 kilograms, and our height is 10 meters. Uh-oh, we have two that are empty. What are we going to do? Well, we always know what gravity is. Even if it's not specifically stated like it is here on this question, okay, it's always known. It's 9.8 meters per second squared. So we always know what gravity is. Now here, potential energy is the unknown. We kind of knew that since it was asking us to calculate potential energy. We already knew that potential energy was something that wasn't there. Okay, so calculate potential energy. Really, that's all we need to know. Calculate potential energy, mass of 10 kilograms, 10 meters from the ground. So that's all we really needed to know to answer this question. So let's go ahead and do that. So we're going to write our formula, PE equals 10 kilograms times 9.8 meters per second squared times 10 meters. Now, something important to point out before we begin these kinds of equations, you'll notice that's in kilograms, that's in meters, that's in meters per second squared. So these are different types of units. Now, the thing is, we can't just cancel them out, and so they're going to end up being kind of together. And so what we'll end up with is a measurement of kilograms. Let me get this thing to work. As meters squared over second squared. So instead of having to say all that, what we'll end up actually just calling this is joules. And that's what we measure energy in, is in joules. So we'll just refer to it as joules, or just J, pretty much. So it won't be that bad. All right, so let's go ahead and start knocking this out. So I'm going to go ahead and make this easy on myself. I'm going to start with 10 times 9.8. So that's going to give me potential energy is equal to 98 kilograms times meters per second squared. Okay, and I still got to multiply it by 10 meters. This is fairly simple now. So now I have potential energy is equal to 980 joules. So 980 joules, which really easy equation right there. Now, just to kind of show you guys, on the last slide we talked about, or on a previous slide we talked about how increasing the mass or the distance would increase the potential energy. And so that's exactly what I'm going to do here. I'm going to change this up here. It's no longer going to be a 10 meters. We're going to make this 20 meters. And so we're going to get rid of that right there and make that 20 meters. So let's see how big of a jump going just 10 meters higher is going to make this. So we have our formula. We're going to have PE equals 10 kilograms, same size rock, times 9.8 meters per second square, because gravity doesn't change. This time it's going to be against 20 meters. Okay? This time against 20 meters. So, very, very easy thing to do. So, this time we're just going to go ahead and do the same thing we did last time. So, P dot E is equal to 998, okay, kilograms times meters per second squared times 20 meters. And so what we'll do is just multiply 98 times 20. And so last time we had 980 joules of energy. Well, this time we're going to have 1,960 joules of energy. It's quite a big jump. Quite a big jump. Now, yeah, it is just multiplying that by 2, but you see just how much more energy is being put out just by raising something 10 meters and not even changing the mass. So it's the energy that object or system has due to its mass and velocity. And we'll get into velocity later. Basically, velocity, I don't know why this keeps doing that, is speed with a direction. And so it's speed with a direction. So kinetic energy is going to have a different formula than potential energy. So in this case, we have mass and velocity. So our formula for kinetic energy is 1/2 mv squared. Now, this formula makes sure to take it a step at a time. Don't skip steps. Don't skip steps with this. Okay? So let's take a look at how this formula will work. So let's say we have a dog weighing 6 kilograms. Okay? Walked at the speed of 2 meters per second. What is the kinetic energy? So let's underline our important things here in this question. So we have a dog, a weight, more accurately a mass, walked at the speed of 2 meters per second. So we know there's a direction. We're not sure what that direction is, but we know that this dog is moving in a direction. So we have a speed of 2 meters per second, speed with the direction. Okay, and we want to know what is the kinetic energy. So, don't need to know that it was a dog. Here we go. So reading into that question. So we got kinetic energy equals mass volume. Now, we already know what is the kinetic energy, which is right here. So what is the kinetic energy? So we don't know what that is, so that's an obvious. That's what the question is asking us. Okay, so our mass right here is going to be 6 kilograms. And our velocity, 2 meters per second. So we're going to plug this into our formula. So 1/2 times 6 kilograms times 2 meters per second squared. Okay. And so let's go ahead and start working on this. So let's do our square really quick, 2 meters per second squared. So we have K dot E equals 1/2 6 kilograms times now 4 meters per second. So pretty simple so far. We can throw in, so 6 times 4, 6 times 4. So K dot E equals 1/2, and then 6 times 4 is going to be 24. Kilograms times meters per second. Okay, and then we multiply that by 1/2. So if you don't know what 1/2 is, like as far as multiplying, or if you're trying to use a calculator, you could also write 1/2 as 0.5. It's the same thing. They are the same thing, because that's basically what 1/2 means. It's if you divide 1 into 2, it's 0.5. So 0.5 is the same as half. Anyway, so if we multiply that, we're going to get an answer of kinetic energy is equal to 12 joules. Okay, so 12 joules. Now you may be thinking to yourself, well, that makes sense. So now that must mean that everything is going to be ending up being extremely easy and just half of what it is if you multiplied it together normally. If you skip steps, you're going to mess up. So having that, taking the time and doing each step is really important. So let's try a little bit more difficult equation. You may have got the impression from the last one that, if I just multiply those numbers together, I'm going to get what what I wanted. But actually, no. That's one of the rare cases where that works out that way. So we're going to go ahead and put up our equation. Kinetic energy, mass, volume. These are the things we're looking for in this problem. So a man weighing 71 kilograms, it's a mass. So we can put that in there, 71 kilograms. Walked in the speed of 1 meters per second. With volume is speed with a direction. So we have, this thing's not want to work, 1 meters per second. And the question, what is the kinetic energy? So there's our big question mark. And so we're going to go ahead and knock this one out. So kinetic energy is equal to 1/2, okay, times 71 kilograms. And by the way, really quick, if this had been 71 grams or something like that, you have to convert to kilograms for this formula to work. 71 kilograms times 1 meters per second squared. All right, so, well, 1 meters per second squared, but we're multiplying it. So we're going to go ahead and start right there. Now here, 1 times 1 is still 1. I could put the integer up there being 1,000. It's still 1. So go ahead and knock that out. KE equals 1/2 71 kilograms times 1 squared second squared. So that makes our next step really easy. 1/2, okay, 71 kilograms times squared over second squared. Okay, so 1/2, and if you remember, a half, I keep writing that wrong, is equal to 0.5. So we multiply that by 0.5. It's going to tell us our kinetic energy is going to be 35.5 joules. So it's not changing as drastically as the last one. We're not getting as much energy here. Thank you for joining us in this tutorial. Once again, this has been Mr. Holsey of H Squared Sufficiently Understood Science. Don't forget to like, share, and subscribe. And also make sure to check out our other tutorials. Have a great day, and we'll catch you next time.